All right, let's get going on today's meeting. So what we're going to be doing today in statistical analysis and psychology is we are going to continue our look at summarizing data and focus in on correlation. I know the title there says correlation and probability. We'll be getting to probability this week, but today I just really wanted to wrap up correlation. We kind of kickstarted it last time, but we want to take a look at it in a more thorough way so that we really understand what correlation is, because it is one of the most widely used ways of talking about the relationship between two pieces of data, but it's also one of the most widely abused ways of talking about the relationship between two variables. So we want to make sure that we know exactly what it is, exactly how we can use it, what kind of insights can we get from correlations before we put a pin in it and move on to probability. So once again, this is our continuing development of strategies and techniques for what I like to call the statistical elevator pitch. So this is all about taking vast quantities of information, vast quantities of data, and boiling it down into a manner that, number one, makes sense to you and your human mind, but number two, and more importantly, allows you to communicate the point of that data, what that data is saying, effectively to somebody else. Because it is very difficult to understand statistics just by itself. We saw this in the first few weeks. Your mind is not set up to figure out statistics. So the simpler you can make the communication of the data to other people, the better off you are and the more impact you're going to have in psychology. And we are also going to continue today with another Do It With Me demo. So we are going to go back into Excel so we can see how to create and calculate correlations. We're going to take another look at how to make scatterplots, because scatterplots are the way to visualize correlations. And we're going to take a look at a very interesting study on delay of gratification in order to illustrate those concepts. All right, so coming up today, we're going to do our deep dive into correlation. That little R symbol, I'll just call it correlation because you know the hack that I've told you about before. Just so it's on your radar, that is also known as the Pearson product moment correlation, oftentimes also called the Pearson correlation. So in this class, we're only ever going to call it correlation. However, when you go on in your psychology career, you might be reading another research paper and you might come across the term Pearson correlation or Pearson product moment correlation. Just remember this moment right here. It's exactly the same thing. There's no difference. It has three names that are widely used. For consistency in this course, we're just going to call it correlation. But going forward, just remember that word Pearson in the back of your mind is the same thing. So we're going to talk about how we can calculate the correlation between two quantitative variables. Very importantly, how to interpret that correlation, and then how to distinguish correlation from causation by looking at what exactly does correlation tell you. And any single correlation has up to 4 possible implications. And we'll take a look at what those 4 are. Only one of them is causation. And we'll take a look at what the other ones are. So bear that in mind as we distinguish correlation from causation. So we're going to illustrate this with a Do It With Me demo centered on the idea of delay of gratification. So we're going to talk about a classic study by Mitchell et al. That gave rise to what is known as the Marshmallow Test. And then we're going to take a look at a follow-up study by Kidd et al., which were trying to answer questions raised by the Mitchell study, but that could not be answered because the Mitchell study was a correlational study. And in that vein, we'll also talk about one of the limits of correlation by taking a look at a really interesting study on assertiveness and leadership and what is the relation between those two quantitative variables. And it was a really cool study done by Ames and Flynn, and we'll take a look at that when we get to the limits of correlation. So once again, just to kind of remind you, right now we're getting into a lot of kind of technical details sometimes for calculating things. We're getting into maybe some new concepts that you've never come across before. So this is one of the areas where I like to call it a level up moment. So if, again, you're looking at correlation, you're looking at measures of central tendency and variation, and everything is making sense to you, that is great, awesome, continue on the course. But this is one of those moments where oftentimes students enter a stumbling block or hit up against a barrier to understanding. That is completely natural. That is completely typical of the progress of many students. So give yourself a little grace. Don't be too hard on yourself. Go back, review what you need to review the things that you're not shaky on, get that feedback from your homework assignments, from your tests and everything to identify what it is that is holding you back. Drill down into that, make sure you got it leveled up, and then everything else will start to fall into place. And as we continue on with our computer romance, we'll again see how Excel makes things really, really easy. So we'll join us on this COMROM as we take a look at the study on delay of gratification. So this study by Mitchell et al., it was the place where the Marshmallow Test first was developed. And the Marshmallow Test is one of those tests where it actually has made its way into popular culture. So not just psychologists know about the Marshmallow Test. And it really is this extremely, extremely powerful test that, as we're going to see, had really strong predictive power in terms of a child's success, even years after they were tested on the Marshmallow Test. So I'll give you the details of exactly what the Marshmallow Test is when we talk about the Mitchell et al. Study, the nature of adolescent competencies predicted by preschool delay of gratification. So just to tell you how predictive this Marshmallow Test was, children in preschool were given this test, and it was found to predict competencies when they were adolescents. So years later, a decade later, you were still able to predict what adolescents would be doing well, which ones would be highly competent based on their performance on this preschool delay of gratification test. All right, so let me just give you a rundown. So these were children 4 and 5 years old in part 1 of this study. So children 4 and 5 years old were shown 2 sets of reward objects varying in pre-tested desirability. So for example, 1 marshmallow versus 2, and the bell. After asking which of the objects in the choice the subject preferred, so do they prefer 1 marshmallow or 2 marshmallows, the experimenter introduced the child to the contingency. The experimenter indicated that she or he had to go out of the room, but said, if you wait until I come back by myself, then you can have this one, pointing to the preferred object. So they would say something like, if you wait until I come back by myself, then you can have 2 marshmallows. If you don't want to wait, you can ring the bell and bring me back at any time you want to. But if you ring the bell, then you can't have 2 marshmallows. You can only have 1 marshmallow. So they left the room, the clock started, and the time until the child rang the bell was measured in seconds, up to 15 minutes. So this is a quantitative variable. How long did the child wait? What was the delay time? So 0 seconds is a possibility. The experimenter left the room and immediately the bell was rung. And then if the child waited all the way up to 15 minutes, at that point the experimenter returned, and without the bell being rung, they did cap it at 15, and the child was given the 2 marshmallows. So the question is that you were asking is, how long could these children wait? Then what they did was, a decade later, when these children were adolescents, when these 4 and 5-year-olds were adolescents, they contacted these children's parents and gave them questionnaires of competence and coping when these children were adolescents. And these would be questionnaires that asked the adults, the parents, to rate their now teenage children on academic competence. So compared to other people their age, other adolescents, how are they doing academically? And social competence, compared to other adolescents, how are they doing socially? Frequency of problems, compared to other adolescents, how often are they encountering problems? And then coping competence compared to other adolescents, how good are they at coping when those problems arise? So these were ratings that were done on the adolescents by their parents. So this is quantitative variable number 2. So you could either score really low competence, for example, in academic competence, they might say that their children are, really struggling in high school, their grades are really bad, they just don't seem to be learning very much. They would score low on academic competence. Or they might say, hey, they're top of the class, they're learning everything, they're really curious, they have a growth mindset, and they would rate really high in competence. So this is quantitative variable number 2. And then what they did in this study, Mitchell et al. Said, let's see if there's any relation between those two quantitative variables. Let's see if there's a relation between how long these children were able to wait as 4 and 5 years olds and how are they doing now as adolescents. And that's what this table is right here. And we're going to zoom in on this. And just to kind of simplify this table, we introduced it last time, but let's go over it one more time. Just to kind of simplify this, what you see here, for example, in the top, these are the girl subjects, so the female subjects. And then we have right below those, the male subjects, the boys. And we have 51 girls, 36 boys. That's what the N equals 51 means. And N equals 36 means 51 girls, 36 boys. But the data that we're going to look at is the combined sample. So in the analysis, they said, all right, let's take all of the girl subjects, all of the boy subjects, and we'll just combine them. So that's the data that we're going to focus on today. And then over multiple experiments, they collected data on these subjects. And some experiments had a first and second delay. And then another experiment only had one delay. So in some experiments, these experiments over here, they told the subjects, hey, you know what? You can have 1 marshmallow now or 2 marshmallows later. And they saw how long they could wait. And then in the same session, they did another delay trial. And they said, hey, you know what? You can have 1 sticker now or 2 stickers if you wait. And then they did it again. In some experiments, they only did it the one time. We are going to take a look at the data where they combined the first and second delay. So the data that we're going to focus on are these 4 scores down there. And those are the correlation coefficients. And we're going to take a look at exactly what those mean in just a moment, because it occurred to me that last time I kind of introduced this study and then I said, hey, you know what? Let's just dive right in and start calculating correlations. So we need to do a little bit of a rewind. We need to bring it back, come rewind just a little bit, because by the look of some of your faces, I think many of you were maybe in this situation here saying, well, what exactly is correlation? What are these numbers really meaning? And that is a good lesson to learn in statistics, especially in life just in general. Numbers oftentimes are very, very impressive. Numbers are very seductive. When you're doing problems in statistics, one of the big pitfalls that students oftentimes fall into is just looking for numbers, grabbing them and starting to plug them into an equation. But if you don't actually know what's going on, then you're no better off in terms of having the numbers or not having numbers. So what exactly is correlation? We are going to take a look at that first before we dive into the actual results of this. So to illustrate this, we're going to go over some hypothetical data, and we're going to ask, what was the relation between a child's ability to delay gratification? So what was the relation between wait time and later academic competence? So we're just going to focus on that to illustrate what correlation actually is. So if we wanted to correlate those 2 variables, if we wanted to know, do those 2 variables relate to each other? Are they related? Do they have some sort of, I'm trying to not use the word relationship, but relationship with each other? What you would do is you would see if they were correlated. So this is going to be a scatter plot. Down here on the x-axis, we have the delay in minutes. So this is how long was this child able to delay. And then over here, we have the rating of academic competence. So how highly did their parents rate them on academic competence? Higher scores on academic competence means that they're doing better academically. Lower scores mean that they're doing worse. So this is where we're going to have our scatter plot. And let's say that we ran the data and we calculated a correlation. And the correlation, which is a measure of the strength and direction of a linear relationship between two quantitative variables, let's say that correlation came and it was 0. So we got a correlation coefficient R equals 0. What this means is that there is no relation between the two variables. And in a scatter plot, that would look something like this. And what we mean by saying that there is no relation between the two variables, what that means is that if you know something about one of the variables, you have no additional information about the other variable. So if I told you to take a look at academic competence, and I asked you, hey, can you predict, I'm thinking of a subject, can you predict what their academic competence is? Well, it could be any of these subjects, right? Each of these dots is a different subject. And if I asked you, hey, I'm thinking of a particular subject, predict what their academic competence is, you would have no way of narrowing down anything, right? It could be this subject down here with an academic competence of about 65. It could be this subject up here with an academic competence of about 132. Could be any of them, anywhere in between. And now if I told you, hey, I'm going to give you a piece of information. I'm going to tell you that the person that I'm thinking of, they delayed between 4 and 6 minutes. So you're like, okay, well, now I know that they're within that box, but you still have no information whatsoever. And if I tell you, well, wait a second, I'm thinking of somebody else and they're between 10 and 12 minutes, that doesn't help you at all either, because these two variables in this hypothetical situation are not correlated. Their correlation coefficient is 0. And what that means is that if you know one variable, or if you have information about one variable, it doesn't tell you anything about the other variable. And in reality, if you take, in actual psychology, if you take two random variables, this is typically the correlation that you'll see. There are so many things about being human that are independent of each other, that they're just not correlated with each other. This is the typical result when there is just two variables picked at random. All right, so correlations can take a value of 0. They can actually max out at a correlation of 1, and they can also max out at a correlation of -1. So anywhere between 1 and -1 is a possible correlation value. And what the correlation number actually tells you, it tells you two things. The size of the number tells you how strong the relationship is. And then the sign of the number tells you in what direction does the relationship go. So the closer you get to 1 or -1, the stronger the relation is between the two variables. And positive correlations means that as one variable increases, the other variable also increases. So they are related in the same direction. A negative correlation means as one variable increases, the other variable decreases. They're still related, almost like very strongly, but in the opposite direction. So a correlation of 1 will look like this. It's the strongest you can be, positive correlation, and it looks like this. And in this case, if I give you information about how long a subject delayed, you can tell exactly what the academic competence of that subject is. So for example, I'm showing you here a window, but if I told you, hey, this subject that I'm thinking of, they scored 5.7, and that correlation is 1.0, you can say, oh yeah, boom, it's that one right there. That's a correlation of, that's an academic competence of 91. So a correlation of 1 means the strongest relationship possible. And as you can see, when you get information about one variable, it tells you everything about the second variable. Now, the correlation of 1, it's sort of a desert oasis that you need to be aware of. It's kind of like a holy grail, but something that you never actually want to achieve. So the higher a correlation, the stronger a relationship is. And that's what we want to find in psychology. We want to find these strong relationships, these variables that go together, because then we can start to affect change and behavior. That's what we're looking for. However, a correlation of 1 never happens in psychology. If you ever see a correlation of 1, it means one of two things. Either you're measuring the same thing, but with different scales. So if I was doing a study on human beings and I measured their height in feet compared to their height in the metric system, I would get a correlation of 1, because I'm just measuring the same thing with 2 different scales. If I wanted to measure their weight in pounds and their weight in kilograms, I would get a correlation of 1. So it's either going to be uninteresting because you just measuring the same thing on 2 different scales, or more likely you entered your data wrong. So if I, in the delay in minutes, put their delay in minutes, and then in Excel, I accidentally copied the scores for delay in minutes and I put those in academic competence and I ran the correlation, I would get a correlation of 1 because I entered the data in incorrectly. So you want strong correlations. You're hoping for strong correlations, but you don't want to get to 1 because 1 means that you made a mistake. Also notice that this is a positive correlation, which means that as you increase the delay in minutes, you also increase the competence of the subject. Or I should say that in a non-causal way, as the delay increases, so too does academic competence. All right, so what about the opposite extreme, a correlation of -1? Well, a negative correlation looks like this. A correlation of -1 would be the strongest positive negative correlation. And these work exactly the same. They're a measure of the relation between 2 variables. But what we're saying now is that as your delay increases, your academic competence actually goes down. So for higher levels of delay, that actually decreases your academic competence. So we've now seen the 3 kind of extreme cases. We've seen no correlation, which is 0, positive correlation maxed out, which is a correlation of 1, negative correlation maxed out, which is that -1 correlation. What about more realistic types of correlations? What do those look like? Well, if you have a correlation of 0.7, that, and here's some hypothetical data for it, that will look like this. And as you can see, it's kind of scattered. It's kind of, a cloud of data points. However, if we were to draw a line through this, a line of best fit, what you can see is that there is definitely a tendency for academic competence to increase when delay also increases. And this correlation of 0.7 means, again, that if I give you information about delay, you might not be able to tell exactly what academic competence is going to be, but you can start narrowing in and narrowing that variability, because you can see the academic competence that occurs between 4 and 6 minutes of delay is much lower on average than the academic competence that occurs between 10 and 12 minutes of delay. So again, as delay increases, so too does academic competence. Not perfectly, there's variation, and that variation is captured in that correlation coefficient of 0.7. All right, and then the weaker a correlation is, the lower the number will be. I should say that another way, the closer to 0 it will be. So a correlation of 0.3, still a positive relation. It will look something like this. So again, we can draw a line of best fit through this, and we can see that in general, as delay increases, so does academic competence. But this time, it's just a weaker relationship. There's more spread. The cloud is more spread over. But you can still see that between 4 and 6, you get a different distribution of academic competence than you do between 10 and 12. So it's giving us some information. It is somewhat predictive, but much weaker, and that's reflected in that 0.3. And then just to kind of round off the analysis, if we have negative 0.3, this is again a weaker relation, but now it's a negative relation, meaning that as delay increases, now academic competence decreases. And then finally, a negative 0.7 correlation coefficient, much tighter spread of data, much more concentrated around that line of best fit. But again, this is a negative relation. So as your delay increases, the distribution of academic competence actually decreases. So that's the basics of correlation. That's the basics of what that correlation coefficient number actually means. Any questions about that before we take a look at the Mitchell study and the Marshmallow Test? All right. So on to the Marshmallow Test. Okay, so now that we kind of know what correlation stands for, we can take a look at the correlation coefficients that they calculated for success on the Marshmallow Test versus those measures of competence later in their academic life. So for this, again, we're going to focus in on the combined subjects, so the boys and the girls, and we're going to take a look at academic competence, social competence, frequency of problems, and coping competence. Those are the correlation coefficients that they calculated, and now we're going to see how they calculated those with a do it with me demo. So if you haven't already, open up your delay of gratification demo Excel sheet. It should look like that. And we will begin with the demo and how we can calculate correlations. All right, so while people are opening this or getting to that window, I'll just mention how this is set up. So in the columns here, we have participant, we have delay. This is how long they delayed in minutes. And then we have their scores for academic competence, social competence, frequency of problems, and coping competence. And again, each row here is a single subject. So this is subject number 2. They were able to delay for 11 minutes. And as adolescents, their parents rated their academic competence at 94.1, their social competence at 103.4, their frequency of problems at 97.1, and their coping competence at 120.5. So those numbers are not going to really mean much to you because we don't know what scale they're on. But just to reiterate, the higher your academic competence, the better you're doing academically. The higher your social competence, the better you're doing socially. The higher your frequency of problems, the more problems you're encountering. So that one is the one that you don't want a lot of. And then the higher your coping competence, the better you are at dealing with problems when they arise. So down here we have subject 10. They were only able to wait for 7.8 minutes before they rang that bell and cashed in and only took the one marshmallow. And then you can see their academic competence, 100.2, social competence, 126.4, frequency of problems, 59.3, and then coping competence, 118.1. So the first thing that we're going to do before we calculate our correlations between delay and those 4 other variables is we want to make sure that we take a look at our data. So to do this, we are going to make scatter plots of these one by one. So we'll make a scatter plot and then we'll calculate the correlation coefficient. So to do this, we're going to start here with delay, and we can start with the first score. And we are going to hold shift and press the arrow key left to highlight delay and academic competence. And then we're going to go control shift and we're going to press the arrow key down, and that's going to highlight all the scores. Okay, so first thing we need to do is just highlight all the scores. So we can start on the first raw score, and then we just hit shift, arrow key to the right, and then control shift, arrow key down, and that'll highlight all of the scores. At this point, it's probably best to scroll back to the top so that we can see that we have everything nice and highlighted. And now we're going to go here to insert. And we're going to go here to the area where we can select charts. So the one that we want is this one right here, Scatterplot. But this will update based on how often you use the charts that are shown here. So if you don't see Scatterplot, you can always click on this little arrow here, and it'll bring down all of the different charts that you can have, and Scatterplot is right there. So we're going to click on that, and we have ourselves our Scatterplot here. All right, so just one more time, we have our data highlighted. We go to insert, we go to our graphs here, our charts. We can hit that down arrow to get all of the charts. The one we want is the scatter without any of the lines. And we click on that, and Excel will generate a scatter plot for us. Now we're gonna drag this so we can make it a little bit bigger, so that we can kind of see what's going on. And we're gonna take a moment or two just to make this look a little bit more presentable, because I'm gonna show you one thing that you can do which is actually really, really helpful when you want to be able to read a chart easily, but you don't necessarily want to make a chart over and over and over again. So to do this, we're just going to erase chart title. So we can click on the chart here. We can click on chart title and we can just hit delete, and that'll erase the chart title. And then we're going to click on the legend down here, and we're just going to hit delete. And that's just going to give us a little bit more space for our data. And then we want to just have this look a way that we like the way that it looks. So this might be different for different people. I'll just show you some of the basics of what I like to do. I find these lines here very distracting. So if you do as well, what you can do is you can just click on them and hit delete, and just click on the line and hit delete. I like a nice clean graph. And then the other thing that you can do here is that you'll notice that we're not really making good use of our y-axis here. So we have all of our data displayed. Excel did a great job of saying, okay, we're going to make the axes big enough so that you can see all your data, but it's kind of all scrunched up here, and it's not really being displayed in a way that is easy for your mind to understand it. So what we're going to do is we are going to click somewhere where there's an empty cell. So we can click over here, and we're going to calculate the minimum for the y-axis. So the y-axis here, this is academic competence. We're not going to label it because we're going to see why in just a moment. And this x-axis here, this is your delay in minutes. And we can actually label that one, but we'll just keep it consistent, because this is less about doing these graphs and returning to it later. This is about us just doing something quick in the moment so that we can see what the relations are. So we're going to click on an empty cell. Any empty cell will do. And we're going to put in equals, and we're going to put in min, so equals min, because we want to calculate the minimum value. And we're going to highlight, we can actually highlight the entire cell or the entire column by clicking on the C above academic competence. And you can see that we now have the minimum of the entire cell. Close those parentheses, hit enter. And you can see here that our minimum is 69.25. So that is the lowest that this y-axis needs to go. So we're going to remember that, and let's cheat a little bit on lower than this. So we're going to go 60. So we can double click on this y-axis here, and it will bring up this chart format, your vertical axis toolbar here. And here where it says minimum, we're going to change that from the default that is 0, and we're going to change that to 60. So we just highlight it, change it to 60, hit enter, and then we can close this, and you can see now that we have a much nicer chart. It's much more spread out. It looks better. This kind of makes more sense to me. So we'll get rid of that calculation there because we don't really need it anymore. And now we have ourselves a nice little chart, nice little scatter plot, and we don't really have a lot of information of exactly how is this relationship, what is the direction of this relationship, how is it correlated. So to do that, we are going to, again, click into our graph, and we're going to hover over a point until you get that little arrow. So when you see this quadruple arrow cross, that means that you're picking or highlighting or about to click on the chart. But if you go to one of the data points, as soon as you're over a data point, not only would it very nicely tell you what the X and the Y points of that data is, but it also turns into just a cursor arrow. That's what you want. And we're going to right click on that. Once we find one point, we don't need to, it could be any point. We're going to right click on that. We're going to go down here to add trend line. And what this will do is it will add a line of best fit. So we add a trend line, and it adds this trend line right there. And now we can see that, okay, we have a positive relation. This is, number one, it's positive. So as delay increases, so too does academic competence. So it's a positive relationship between these two variables. And then now that we know that it's a positive relationship, we can also just kind of visually take a look and ask ourselves, is this a linear relationship? That means, does this cloud of data, is it best expressed by a straight line? And what you're looking for is you're looking for an even distribution of points above and below your line throughout the entire line. So here at the beginning, we kind of have an even distribution above and below the line. Here in the middle, we have an even distribution above and below the line. Here at the end, we have an even distribution above and below the line. That's your indication that, yes, you are dealing with a linear relationship. So now that we have created this scatter plot, we know that it's a linear relationship. We know that it's positively related. Now we can finally say, all right, let's actually calculate that correlation coefficient. We've looked at the data, we've looked at a picture of it, we've assessed that a correlation coefficient is the way to describe this relationship because it's a linear relationship. So now we can finally go, all right, Excel, we're gonna click on this cell here. We're gonna put in equals. The formula for correlation is CORREL, so it's just CORREL. Very nicely, Excel lets you know, this returns a correlation coefficient. It's exactly what we want. You open your parentheses, it'll tell you that it's looking for array 1 and array 2. Array 1 in this case is going to be delay, so we just click on the first data point in delay and we can control shift and go all the way down. And we can scroll back up and we have all of our delay data chosen. And then we put in, very importantly, a comma. That lets Excel know that we are now ready to give it the second set of data. We click on academic competence, the first score, control shift, down arrow key to highlight all of the other scores. We can scroll back up with our mouse. We can close those parentheses and we get a correlation coefficient of 0.27. So this is telling us that we have a positive relationship between delay and academic competence. So the more you were able to delay as a child, the higher your academic competence as an adolescent. So more delay as a child is related to higher academic competence as a teenager. And the strength of it is 0.27. And I really wish there was an agreement on how high a correlation coefficient do you need to call something a strong relation, a medium relation, a weak relation. There is no agreement. So everybody can agree that that correlation coefficient is 0.27. Everybody can agree that it's positive, that as delay increases, so too does academic competence. But then it's up to personal opinions and subjective judgment as to whether you consider that a strong relation or a weak relation. But we have calculated that 0.27. Is everybody with me so far? Everybody got to there? Okay. So the next thing we want to do is we want to calculate social competence. Now we could start this whole thing over and do this graph all over again and redo the axes and add another trend line. Or what you can do is if you're just wanting to take a look at the data before you do the calculations and you don't need to hang on to your graphs, you don't need to keep them. What you could do is you just go to the graph and again, you're looking for this cross, these arrows that cross, these 4 arrows that are crossed. And we're going to right click on the graph and we're going to go down here to where it says select data. Okay, so once again, you're in the graph, you have that 4 arrow cross, you're going to right click on it and we're going to choose select data. And then down here, it'll tell you where your source is and it'll tell you where your setup is. The setup is what we want. And down here, it'll say series 1. This is what we want to expand. So we're going to go over to this arrow here and we're going to expand series 1 and it tells you what your X values are and it tells you what your Y values are. Now the X values here, if you click on them, Excel will highlight exactly what your X values are. That's the delay. And we don't want to change that because we want to now correlate social competence with delay. We want to see how social competence related to delay. So those X values, we're going to keep exactly the same. So we can click on this little check mark here. But these Y values, we now want to switch from academic competence to social competence. So what we're going to do is we can do this a number of different ways. One way is to just have this highlighted all in blue here. So when you click on it, it highlights it all in blue. Go over to your Excel sheet, click on the first score of social competence, and you can see here that it said, okay, your X values now are D2, just that one score. Well, that's not what we want. So we're gonna go Control Shift arrow down. We highlight the entire set of social competence scores. And then when we click on this little check mark here, watch the graph. As we click on the little check mark there, the graph updates with the new data. So now we can close that change the data toolbox there. And we have this new chart. And this new chart is now the relationship between delay and social competence. And again, we can take a look at the chart and we can say, well, hey, it's a positive relationship. It's a linear relationship because that line looks to pretty much fit very well with all of this scattered plots of data. So we know that a correlation coefficient is what would make sense. So we go up here to social competence and we put in equals CORREL because we know we want that correlation coefficient. We highlight delay and highlight all of the data with the Control Shift down arrow key. Put in your arrow. Now we're going to highlight social competence. And we Control Shift down arrow key to highlight all that data. Close your parentheses, hit enter. And we can see that here, social competence has way too many decimal points for my liking. So since we have too many decimal points here, we're going to go up here to the toolbar. And we just really hover here, decrease decimal, increase decimal. The one that we want is decrease decimal. And we can see that we have a social competence score of 0.39. So that is how they did the calculation, Mitchell et al., to find out that social competence is 0.39. And again, we don't know, or we can't really come to an agreement as people, as scientists, as psychologists. Is 0.39 a strong correlation? Is 0.27 a weak correlation? But what you can say for sure, is that social competence is more strongly related to delay of gratification than academic competence is. So whatever is causing this relationship, it is making a stronger relationship between delay of gratification and social competence than it is between delay of gratification and academic competence. All right, next one we're going to do is frequency of problems. Frequency of problems, again, we're going to right click here on your graph. We're going to go to select data. We're going to go to setup here, so data, setup, series one, open series one. We're going to go down to the raw scores here. We are now going to choose frequency of problems. So we're going to change social competence to frequency of problems. Click on that first score, Control Shift all the way down. Put the check mark once you're done. Scroll back up and you can see that our graph is once again updated. And here you can see that that line is almost flat. So that line of best fit is almost flat. And a flat line of best fit means that there is no correlation. There's no relation between these two variables. So immediately, just visually, we know this is going to be a correlation coefficient that is going to be close to zero. So let's see exactly what it is. We click on the cell where frequency of problems and delay intersect. We put in equal, CORREL. Open those parentheses, choose delay, Control Shift, get all of that data, put in your comma, choose frequency of problems, Control Shift, get all of that data, close your parentheses, hit enter, decrease those decimals because those are way too many decimals. And you can see that the frequency of problems correlation is 0.05. It is almost zero. There's basically no relationship between delay of gratification and frequency of problems. And this one actually makes a lot of sense when you start thinking about it, because regardless of how good you are at living life, everybody encounters problems. Everybody encounters challenges. Everybody gets rained on. right? Everybody gets a flat tire. So frequency of problems is not really going to go down regardless of what you do. So that kind of makes total sense, that you could be a child that could delay gratification for hours or a child that couldn't delay gratification for 10 seconds. You're still going to run into basically the same amount of problems. All right, and the last one here, coping competence. When those problems arise, how good are you at actually coping? So once again, don't want to redo the graph. So we're going to right click on it, select data. We're going to go back down to the setup for series 1. And then we're going to click on the Y values, because the X values, we still want it to be delay. But the Y values now, we're going to change to coping competence. So we click on that first data, control shift, arrow all the way down. Check that the raw scores are highlighting the correct data, hit check. Scroll back up, and we can see now that our graph has updated. Has it updated? Did I do that right? I did. All right, well, I did it right. It really doesn't look that much stronger than the one that we just took a look at, but that's what it looks like. We're going to calculate the correlation coefficient. So CORREL, open parentheses. Let's highlight that delay, put the comma, and then we're going to highlight coping competence, close the parentheses, hit enter, and we see that coping competence is correlated about 0.23. So definitely weaker than the other social competence and academic competence. This was a little bit surprising to me that the graph didn't really seem to change very much. But then again, that's why we have, this is a great example of why we calculate these numbers. Because right here, live and in person, you just saw a experimental psychologist that does this for a living take a look at that data and say, that doesn't really look like there's any relation there. But then when you calculate out the actual competence, it's a 0.23 correlation coefficient. There is something there. Perfect example of why we're developing these skills, so that we can actually see the truth of the matter and not just what one scientist might mistakenly perceive. All right, any questions on anything that we did with the Excel sheet? All right. So that was the Do It With Me demo. And as you can see from this, these results in this study, the ability to delay gratification when you are 4 and 5 has very powerful predictive power for when you're an adolescent. So that was one of the big findings from the Nature of Adolescent Competence Predicted by Mischel, that this one little test that indicated how well you are delaying gratification had very profound implications for how well you were living your life as an adolescent. However, this is a correlational study. And because it's a correlational study, it has limitations. So a correlational study, by its very nature, has limitations because it does not allow you to make causal inferences. And we're going to see exactly why right now. So let's zoom in on this data here. And we're going to take a look at each of these in turn. So we have delay and academic competence. So we know that there's a relation between those two. We just calculated that relation, that correlation between the two of them. That is not in dispute. So whether or not these two variables are correlated is not in dispute. The question is, why are they correlated? And if we as psychologists are going to be doing interventions, then the why is incredibly important, incredibly important. So the question is, why are they related? And when you're dealing with correlation coefficients, there are always 4 possibilities that you need to keep in mind. And we need to be very diligent about keeping these in mind, because your mind has evolved to see causation where there is no causation. Your mind has evolved to link together things that aren't supposed to be linked together. So you have to fight against that by entertaining these 4 options anytime you see a correlation. So why are they related? Let's go through the 4 options. Option A, this is the least interesting option, but it's a possibility. Option A is that there's just a chance occurrence. So it might just be that these 2 quantitative variables, academic competence and delay, they're just related by chance. And if we ran this study again, or if we went to a different Earth in a different multiverse, these 2 actually wouldn't come up correlated. It was just a chance occurrence. Now, as we go further in statistics, you're actually going to be able to determine how much of a chance occurrence is this. So these 2 little asterisks over here, if you look down here where the asterisks are explained, those 2 asterisks are telling you that the p-value for that correlation is 0.05. Now we are going to talk about p, or less than 0.05. Now we are going to talk about p-values a lot when we get to inferential statistics. But what I want you to know right now is that this p-value, that is your p probability that this correlation came from chance, was just a fluke occurrence. So that probability is less than 0.05. That probability is less than 5%. So we might have a less than 5% chance that this is just a random occurrence, but it's important to keep it in mind, right? Because it's always a possibility. And when people don't keep in mind chance occurrences as a source of correlations, that's where conspiracy theories come from. When people see things that go together and don't realize, well, hey, maybe they just randomly occur together, but that's a TED Talk for another time. All right, so that's option A. Option B. Option B here is that you have a relationship between delay and academic competence because delay actually causes academic competence. So this is a possible reason for this correlation. And what this means is that the ability to delay gratification as a young child is actually what causes you to be good in school by the time you're a teenager. So the ability to say, hey, you know what? I'm not going to watch TV today. I'm going to delay my gratification and I'm going to go study. So it's actually the delay of gratification that causes your academic competence. That might be one of the reasons why we have that correlation coefficient. But it's important to remember that's only option B, that the delay causes academic competence. And that's where most of our minds would jump to. But again, that's only option B. Option C is the other direction of causation, that academic competence actually causes delay of gratification. So maybe children that are more intelligent, maybe children that are just better at school, better at learning, better at figuring out what this world is all about, maybe they're able to figure out, hey, you know what, delay of gratification, that's actually a good strategy. It's not that I want to, it's not that it's any easier for me, it's not something that I naturally have a skill, but because of my academic competence, because of my intelligence, I can figure out this world and say, hey, you know what, delay of gratification, that makes sense. So in this case, academic competence, having the skills that makes you good in school, that actually causes your ability to delay your gratification. So that's option C. And it's important to know the difference between these 2 options, because if you were an educator, if you were an educational psychologist, and you said to yourself, I want to increase the academic competence of my students, what is something that I can do? What's an intervention that I can do? Well, if option B is true, then you can start a program that works on teaching delay of gratification. Because if option B is true, if you teach a child how to delay gratification, that will cause academic competence. So as an educational psychologist, you can increase academic competence. It would be a huge win. That's if option B is true. If option C is true, and academic competence is what causes delay, you can teach delay of gratification. It's not going to do anything for academic competence. It's going to be a waste of your time. It's going to be a waste of your students' time, and you're going to be spinning your wheels, not making any difference. So it's important to know what that direction is. And then option D, and this is one that is the tricky one, is that there's actually a third variable, a mystery variable, and this causes both of them. So there is a third, as yet undiscovered, unseen variable that causes both academic competence to increase and your ability to delay gratification. It increases both of those. So those are your four options. One, chance occurrence. Two, academic competence is caused by delay. Three, delay is caused by academic competence. Or four, a third variable causes both. Now, the Mitchell et al. Study, because it's correlational, can't tell you which one of those four, other than option A. It's not option A. They ran the stats, so it's not option A, but they can't tell you if it's B, C, or D. So in order to do that, what you need to do is you need to run an experiment. You need to run an experiment where you tell students or subjects, half of you are going into this condition and half of you are going into this condition. So if it was possible to say half of you are going to delay gratification and then half of you are not going to delay gratification, then the Mitchell study could have been an experiment. But since that's not possible, you have to look for other possibilities. And that's what we're going to wrap up today with when we take a look at the Kidd et al. Study, Rational Snacking and Young Children's Decision-Making on the Marshmallow Test. So this study here was an extension of the Marshmallow Test. But what they did here is they had two other conditions or two other choices that the subject went through before they encountered the Marshmallow Test. So I'm going to read this out. So the first choice was the crayon test. So for choice one, the researcher presented the child with a small set of well-used crayons in a tightly sealed wide-mouthed jar. The researcher explained that the child could use the crayons now or wait until the researcher returned with a brand new set of exciting art supplies to use instead. The researcher then left the room for 2.5 minutes. All children waited the full 2.5 minutes. So they were tempted with these crayons that weren't so great. And they were told, if you're able to wait, we'll give you this exciting set of art supplies and we can draw some really, really cool pictures. So all children waited the full 2.5 minutes. And the reason is because they made the crayons in the jar near impossible to open. So this first choice was set up for the children to succeed. They wanted to get them to succeed. And the reason that they wanted to get them to succeed is because of what happened next. So half of the children in this study were placed in the reliable condition. And in the reliable condition, the researcher returned with a rotating tray featuring a large assortment of exciting art supplies. In the reliable condition, the experimenter kept their promise. That's half the subjects. The other half of the subjects were in the unreliable condition. And when the researcher returned in the unreliable condition, they returned without the promised art set and provided the following explanation. I'm sorry, but I made a mistake. We don't have any other art supplies after all. Why don't you just use these instead? So in the unreliable condition, a promise was made, the child waited, promise was not delivered on. That was choice number one. Then after drawing for a little bit and having a little bit of time between choices, they went on to choice number two, and this was the sticker test. So for choice number two, the researcher produced a round 1.25-inch reward-style sticker from their pocket, sealed inside of a plastic envelope. The researcher explained that they could use the small sticker now, or they could wait until the researcher returned with a large number of better stickers to use instead. The researcher then placed a small sealed sticker in the center of the table and left the child alone in the room to wait for 2.5 minutes. Once again, designed so the child would be successful. All children waited the full 2.5 minutes. In the reliable condition, the researcher returned. So again, the same subjects that were in the reliable condition for choice one stayed in the reliable condition for choice two. The researcher returned with 5 to 7 large die-cut stickers featuring a desirable theme like Toy Story or Disney princesses. And these were selected by the parents of the children in advance to make sure that they were rewarded. So that's a reliable condition. In the unreliable condition, the researcher returned without the promised stickers and provided the following explanation. I'm sorry, but I made a mistake. We don't have any other stickers after all, but why don't we just use this one instead? So in the reliable condition, the subjects that were in the reliable condition, they now had 2 experiences with this researcher where promises were kept. And in the unreliable condition, these subjects had 2 experiences with this researcher where they waited and the promise was not kept. And then finally, they got to the marshmallow test. And in the marshmallow test, the task immediately followed the other 2 tasks. Once the table was cleared, the researcher revealed a single marshmallow to the child and provided the following explanation. You finished just in time because now it's snack time. You have a choice for your snack. You can eat this 1 marshmallow right now, or if you can wait for me to go to get more marshmallows from the other room, you can have 2 marshmallows to eat instead. How does that sound? Wait for a response. Okay, I'm going to go get more marshmallows from the other room and turn your picture into a cup, blah, blah, blah. Can you wait? Can you do that? I'll leave this marshmallow right here. And if you haven't eaten it, when I come back, you can have 2 marshmallows instead. And then they leave the child alone for 15 minutes. So that was a setup. Now, in this case, we have an experiment because we have 2 different groups of subjects, children in the unreliable condition and children in the reliable condition. And importantly, they were randomly assigned to each condition. So there is no difference in general between the children in the unreliable condition and the children in the reliable condition. So children in the unreliable condition would have the same distribution of IQ as the children in the reliable condition. Children in the unreliable condition would have just as many dog and cat owners as children in the reliable condition. So any characteristic that you think might impact the study is probably being balanced between the 2 conditions because you randomly said to every single child, you're going to go in this condition, you're going to go in this condition. You wouldn't tell the child, but they were placed into either unreliable or reliable conditions. So we're going to see a graph here of the results. On the x-axis there, we have the categorical variable. Were they in the unreliable condition or were they in the reliable condition? And then on the y-axis here, we have the quantitative variable of how long did they wait on the marshmallow test. So how long were they able to wait before they ate that marshmallow and weren't able to delay their gratification to get to the 2 marshmallows. So we have here the data for the unreliable group. So the unreliable group lasted about 3 minutes. So they were able to wait approximately 3 minutes before they ate the 1 marshmallow instead of waiting for the 2 marshmallows. So that's on average. Incidentally, when you see bars like this, we'll talk more about what these are as we go through the course, but this is not a box and whisker plot. So it kind of looks like a box and whisker plot, but it's not a box plot. This is a different type of graph. But for right now, we can ignore these. Well, we can ignore these, gesturing to myself. We can ignore these little bars here and just focus on the height of the bar. Unreliable, children in the unreliable condition who had the unreliable experimenter, I don't want to disparage these children indirectly, they could only last about 3 minutes. What about the children in the reliable condition? How long were they able to last? That's how long they were able to last. They were able to last, on average, 12 minutes. That's the average, knowing that the cutoff was 15 minutes. So the most you can maximize this was 15 minutes. So many of these children made it all the way to the end. And if they didn't make it all the way to the end, they made it very, very close. And here we can see that what is causing, because it's an experiment, we know that what is causing this ability to delay gratification is whether or not you're in a reliable environment or if you're in an unreliable environment. That is what is causing the ability to delay gratification. So is that clear to everybody? Any questions on why we can say that it's the environment, unreliable or reliable, that's causing the delay of gratification? All right, awesome. Okay, so now that we have this information here, that an unreliable environment leads to low delay of gratification ability. A reliable environment leads to a high delay of gratification ability. Now we can go back to the Mitchell et al. Study and take a look at academic competence. And again, we think about the options. Option A, chance occurrence. We've already ruled that one out, probably not. Option B, delay causes academic competence. We still have no information on that. That's still a possibility. Option C, academic competence causes delay. We still don't have information on that. It remains a possibility, but we now have information that a third variable might be able to cause both. And that third variable is possibly environmental reliability. So what I want you to think about right now is we saw how environmental reliability affected delay of gratification. Where in a child's life, a 4 to 5 year old child, where does their environmental reliability come from? Think back to when you were 4 and 5 years old. Were you able to stabilize your own environment? No. Were you able to provide for yourself? No. Who did that? I'm gonna pretend I heard parents. Okay, so I saw lips move. Your parents did it, right? Your parents provided the environmental reliability. Now, if you have the type of parent who keeps their promises, who interacts with you, lays down conditions, and then when you satisfy those conditions, keeps their promises and rewards you with what they promised you, are those the types of parents that are more likely or less likely to take an interest in their child's academic abilities and make a difference? Do you think they're more likely or less likely? More likely. Yeah, they're more likely. I know sometimes it's just not. They're more likely. So the parents providing a stable environment for their children was why at 4 and 5 they were able to delay gratification, because they saw that authority figure, they saw that experimenter, and they said, well, hey, this person is a lot like my mom or dad. They're a lot like my parents, and my parents keep their promises. I bet you he's coming back with 2 marshmallows. So I'm going to wait. I'm not going to take this 1 marshmallow right now. I can delay because I know I'm getting 2 marshmallows later. But if you came from an unreliable parental environment, where by 4 and 5 years old, promises were broken, parents said, you know what, we're going to go out this weekend. If you do good in school, if you bring home a good report card, we're going to go to the park and we're going to have a wonderful time. And you studied hard and you brought home those A's and you're like, hey, mom, dad, check it out. I got all A's. We're going to the park this weekend, right? And they're like, oh, yeah, I'm sorry, kiddo. Not this weekend. We can't go. But great job. We're whatever. If they lived in that type of an environment, then when they took a look at those experimenters and the experimenters said, hey, you delay your gratification and I'm going to give you 2 marshmallows. They looked at that experimenter and said, you know what? This is a lot like my parents. My parents don't keep promises. I'm going to take that marshmallow now because I don't know what's going to happen if I wait. So in this case, the environmental reliability causes the delay of gratification. And then that same environmental reliability, the reliability of those parents, causes academic competence. It causes the type of environment where somebody is looking over you, putting contingencies in place that is rewarding you for developing your academic skills, or not watching over you, not putting contingencies in place to help you develop your academic skills. Worse off, promising things if you work on your academic skills, but then not delivering, promising that they'll help you with your homework, but then not delivering. So it's not that delay of gratification is causing academic competence, it's that environmental reliability is causing delay of gratification, and that environmental reliability is then causing academic competence when they are teenagers. Same thing with social competence. Once again, if you live in an environment where your parents are teaching you how to deal with other people, how important it is to keep promises, how important it is to mean what you say and say what you mean, how important it is to not flake out on people and not cash in early and do all those sort of things that are the hallmarks of sociopaths, you're probably going to be way more socially competent than somebody that lives in an unstable environment where, again, promises are broken, relationships are not formed, relationships can't be maintained because there's so much betrayal and disappointment. Interestingly, though, frequency of problems, you'll notice, has no effect on delay of gratification. And that is because you can have an environment that is reliable. And if anybody here is a parent, you will know this to be true. You try your best to protect your children from the problems of this world, but it really doesn't matter if you try super hard, and it really doesn't matter if you don't try at all. Those problems are going to find your kids. So the frequency of problems not being correlated also makes complete sense, because you could be in a very stable, reliable environment. You're still going to encounter problems. You're still going to maybe get bullied at school. You're still going to maybe get injured when you're playing on the playground. You're still going to maybe fail a test. You're still going to have your heart broken, by your boyfriend or girlfriend. These things are going to happen whether or not your parents are giving you a reliable environment. But coping competence, that again is related to that environmental reliability, probably here caused by, again, the parents. So again, if you have that environment where your parents are taking an interest in you and saying, hey, we'll help you out. And then they actually do help you out because they keep their promises and they teach you how to cope and they teach you the strategies and they teach you that you're safe in this environment because you don't have to worry about the promises that they made. You're probably going to be way better at coping with whatever life throws your way than if you know that you have nobody you can rely on, which is a horrible thing to feel when you're a child. If you're a child and you're supposed to go out there and explore the world and take risks and try things out just to kind of find how you fit into the world, and in the back of your head, you're like, well, I have no safety net. My parents are completely unreliable. They've been showing me that since I've been 5. You're not going to be able to cope. You're not going to be able to have those skills. So again, coping competence related, not because it's related to delay of gratification, but because environmental reliability causes delay of gratification. Environmental reliability causes coping competence. In this case, option D evidence has been provided for option D that it's a third variable that is causing both delay of gratification and all those competencies, and that third variable is environmental reliability. All right, so we are going to wrap it up at this point right here. We do have, I keep running out of this, but we do have one last little thing that I want to point out on correlation. We'll do that next time. It has to do with leadership and assertiveness and this wonderful study that was done by Ames and Flynn. So we are trying to make leaders here, send you out into the psychology world so that you are leaders. So this is a great thing to know for all you future leaders, but it's also going to be our look at limitations of correlation. But we will get to that next time. As for our meeting today, that is it for today.